again in the third module. In this module, you will learn about the exponential smoothing model. Exponential smoothing method is a method for continuous changing estimation or forecast by considering the fluctuation in the data. There are three types of exponential smoothing. The simple exponential smoothing or the single exponential smoothing is a method with only one parameter and allows forecasting for series with no trend and seasonality. Double exponential smoothing, or also known as Hawk method, make use of two parameters and suitable for data with trend. And the triple exponential smoothing, or also known as the Hawk-Winters method, involve three smoothing parameters to smooth the data and is suitable for data content, trend, and seasonality. The simple exponential smoothing method is used for time series data that have no trend and when the mean or level of the time series is slowly changing over time. The single exponential smoothing model can be written as. Now, let's see some video demonstration on how to model the data by using single exponential smoothing model in Excel.
Now, let's start the first tutorial for single exponential smoothing model. This model is appropriate for data that have no trend or seasonality. So let's say this is our data. Let's see how the data look like when we plot the graph. Go to Insert, Recommended Chart. Choose the plot that we want. Click OK. So from this plot, we can see that the data has no trend or seasonality. So that means this data is stationary. To analyze with single exponential smoothing, we must insert the equation manually. Let's see the equation. The equation is given by where ft plus 1 is the data that we want to forecast, alpha is the parameter value for smoothing constant, yt is the data at time t, and ft is the old forecast for period t. Usually, the value of alpha is between 0 until 1. And we can take the ft as the mean of the yt. To calculate the mean, we can use the formula from Excel. Choose any cell, let's say here, and insert the equal sign. Type average. Choose average from Excel and select the column from the data without including the label. And then click Enter. Now, we have the value of the mean. This value will be used as the FT. Now, we can create a column of FT. And the first value of the FT is coming from the mean value. And we also must create the value of alpha. So we can put it here. We start with the value 0.05. For the second row of the FT, we will insert the value of FT plus 1 coming from this equation into this cell. How to insert this formula? We must follow the equation one by one. So click the cell, and in this formula bar, we insert the equation. Start with equal sign. The formula is alpha yt plus 1 minus alpha ft. So the alpha is 0.05. So we click the cell of the alpha. Multiply yt. So our first yt is 120. So we click this cell. Plus 1 minus alpha. So we open the column, 1 minus, click the cell of alpha again, alpha, close the column, multiply with the FT. Our FT is C2. So, and then we click enter. For the next FT, we will repeat the same process. The FT plus 1 that we will calculate now is F3. So, the equation will become alpha y2 plus 1 minus alpha f2. And if we calculate f4, the equation will become f4 equal to alpha y3 plus 1 minus alpha f3. Since we use Excel, we can simplify the calculation by using sign in Excel. As you can see, when we repeat the process, the value of alpha is remain the same. Therefore, we can simplify the process by adding a dollar sign to the alpha cell. We can add the dollar sign from the first cell where we apply the formula. This is the first cell where we apply the formula. So we can add the dollar sign at G2 because G2 is the alpha value. So dollar sign before G and dollar sign after G. We will apply also the same dollar sign here. Dollar sign before G and dollar sign after G. Click enter, and then from here we can simply drag this cell until the end of the data. We delete first this, then drag this cell. You can check for every row, Excel has calculated the forecast value and change the cell of YT and FT automatically. Since the alpha can take value from 0 until 1, we need to check which alpha gives the best value for the model fitting. To check that, we can use the sum square of error or SSE. But to calculate the SSE, we must calculate the square of error first. The formula of the square error can be given by SE equal to YT minus FT square. YT is the original data at time t and FT is the forecasted data at time t. Now, let's calculate the SE. So this column will be the SE column. So we go to the first cell where it have the first original data and the first forecasted value. Okay, click that cell. Okay, and then go to the formula bar, insert the equation. So equal sign, open bracket, the original data, which is the YT, so in this case the Y1, okay, minus FT will be the F1. Then close bracket, and then insert this side and put 2. Okay, so this is the formula of the SE, YT minus FT square. Click enter. And then from here, you can just simply drag this formula until the end of the data. Now you have SE for every T. Okay, to calculate the SSE, you go to the last column of the SE, click that cell, go to the formula bar, click equal sign, type SUM, okay, and then click sum from the Excel, and then drag the column of the SE and click enter. So this 34.21892 is the SSE for alpha 0.05. So we can make a table, okay, to compare the value of the SSE for every alpha. So I make a table here. So the first column will be the alpha column, And then the second column will be the SSE value column. So for alpha 0.05, we know that the SSE is 34.21892. So you can check for every alpha manually. So for 0.1, 0.2, okay, until 1. Alright? So that means we have to change the value of alpha here to obtain the value of the SSE. So now let's try for 0.1. So when we change the 0.05 into 0.1, click enter, automatically the value of the SSE also will be changed. So for 0.1, the SSE is 35.9755. Let's try for alpha 0.2. For alpha 0.2, the SSE is 39.7769. We will do for all value of alpha that we have written here. So I have calculated all the SSE for all the alpha, okay? So you can see from this SSE value, the alpha 0.05 is the smallest, has the smallest SSE. So that means 0.05 will be chosen as the parameter to fit this data with this model because it gives the smallest value of SSE. Okay, another way for you to find the best or minimum value of SSE and the best alpha with that minimum value of SSE is by using the solver in the Excel. So how can we use this solver? You can simply click solver. Set objective means what value that you want to find or focus on or objective. So in this case, the SSE, right? So we click that cell. And then the objective is to find the minimum value of SSE. So click min. So this value of SSE is depend on by changing variable cells of the alpha, right? So we click the cell of alpha. Constraint. So we know that our alpha is larger than 0 but less than 1. So for cell reference, we click the alpha cell. So we want the value to be less than or equal to 1. Okay, click add. And then another one is the value of alpha, but it must be larger than or equal to, we don't want to take the value of 0, so we can write it as 0.05. Or if let's say you want a smaller value than 0.05, you can write it as maybe 0.01, okay, depend on you. And then click OK. So now we have two constraints, okay? So select a solving method. This one you can choose if let's say you want to use another method, simple LP or evolutionary. So I just stick with the GRG nonlinear. Then I will click solve. Keep solver solution. So they will change the value of alpha if we click this keep solver solution. So I will use this keep solver solution and click OK. So obviously, solver also said that 0.05 is the best alpha value to get a minimum value of SSE. So I hope you understand how to do analysis with exponential smoothing model by using Excel. So after this, we will learn a double exponential smoothing model by using Excel, or also known as hot method. Okay, see you there.